All right, greetings everyone. Welcome to the fourth and final part of the videos on section 3.7. Finish up our study of rational functions here, looking at how to write the equation of a rational function given the graph. So let's get into it. So here on the left, we have a rational function, and we're asked to write the equation of it. And since they didn't tell us what it's called, I'm going to call it g of x. And because we know it's a rational function, okay, we know it's going to be in this form of like a fraction. Remember, rational has that word ratio in it. And ratios are another name for fractions. And so what we want to do is figure out what terms or factors go in both the numerator and the denominator. And let's start with the denominator. And recall from what we've learned earlier in this section is that the factors that go in the denominator relate to the locations of vertical asymptotes. So if we look at the graph here, we see that there are two vertical asymptotes at x equals 2 and also x equals -1. So that tells us that in our equation here, we have to have factors that are made 0 by each of those numbers. So for the x minus 1, we'll have an x plus 1, since plugging -1 in there would give us a 0 in the denominator. And then at the x equals 2, we'll have x minus 2, since plugging in 2 for that would give us 0. Okay, that's the first part of that. The second part, we need to figure out the powers on these. And the way that we do that is we'd look at what the tails do on each side of those asymptotes. So looking at the first one, where the x equals -1, which relates to the x plus 1 factor. Notice that on the left-hand side, the tail goes down. On the right-hand side, the tail goes up. So they're going in opposite directions. So that tells us that the power on this should be an odd power, which in this case would just be 1. So that's for that one. Looking at the second one, for x minus 2, so that's going to deal with the x equals 2 vertical asymptote. And notice that on the left-hand side there, the tail is going up, and on the right-hand side, it is also going up. So the tails are going in the same direction, which tells us that that factor there needs to have an even power, or we're just going to use squared to make it simple. Okay? So that helps us find the denominator. So we should have x plus 1 to the first, or just x plus 1, and then x minus 2 squared. Okay, now let's look at the numerator. Now for our numerator, we know that that relates to the locations of horizontal intercepts. So let's look and see where we have those in the graph, and I see one here at -2, and another one here at 3. So we know when the x equals -2, we're going to have a term up here that is x plus 2, because plugging -2 in there would make that factor 0. Do the same thing at x equals 3. So it's going to be an x minus 3, because plugging 3 in there would make that 0. And then just like we did for the denominator, we have to figure out what the powers are on each of these factors. And we use the same kind of ideas or rules that we had with polynomials. So for the x plus 2 term, or factor, excuse me, I keep saying term, I mean factor. That relates to the x equals -2 horizontal intercept, and notice there the graph passes straight through that, so it doesn't flatten out or bounce. So that tells us the power on the x plus 2 should be to the first power. And then for the x minus 3, well, that corresponds to the x equals 3 horizontal intercept. And notice the graph bounces there. So that tells us this should be to the second power, so x minus 3 squared. Okay. All right, now there's one other kind of important feature we see in this graph we have here, and that's the hole. So notice there's a hole right here at x equals 5. And if you remember from earlier in the section, we have a hole in a rational function if we have a factor that makes both the numerator and the denominator 0. So that tells us because that's at x equals 5, we need to have both an x minus 5 on the top and the bottom. Okay, so we have x minus 5 over x minus 5 there. And again, that's because of the hole. All right, we are almost done here. We just need to figure out what our leading coefficient is. So just like with polynomials where we can have a value out front, I have a similar thing with rational functions. And in order to find that value out front, we need to find another point on the graph that is not a horizontal intercept. I guess if we try to use a horizontal intercept here, everything will cancel out. So look for another point, and often that point would be the vertical intercept, although notice here on this graph, our vertical intercept is kind of hard to read. 0, it looks like it may be 0 and 2 1/4, maybe, it's hard to tell. So let's try to find another point, and another one I see is right here. Looks like it's at the point 1, 3. So we'll go ahead and use those coordinates, plug them in to the function here to solve for the value of a. So we'll have 3 as our output equals, so we have the a times 1 plus 2 times 1 minus 3 squared times 1 minus 5 all over 1 plus 1 over 1 minus 2 squared over 1 minus 5. And multiplying all that out, we would have on the top, looks like we would get negative 48 times a. On the bottom, you would have negative 8, which negative 48 over negative 8, that becomes positive 6. And then we can divide by 6 on both sides. And it looks like when we do that, we end up with a equals 1/2. Okay. All right, so then up here in our equation, we can replace the a with a 1/2. We can either put the 1/2 up with the numerator, or we can put it out front. So it's the same thing. I'm just going to put it out front this time. And so this would be our equation here. G of x equals 1/2 times x plus 2 times x minus 3 squared times x minus 5 all over x plus 1 times x minus 2 squared times x minus 5. All right, thanks for watching. That's it for now.